Hello everyone, I am Professor Pokharkar from ENTC Department of ASSMS Institute of Information Technology, Pune. So today I will give the introduction about capacitors and capacitance. So capacitor and capacitance. The capacitor is nothing but any two conductors, one with positive charge and other with negative charge. So there exists a potential difference between the conductors, that is V. So Q is equal to CV, where C is the capacitance. The unit for capacitance is farad. So usually the capacitor are used for storing and releasing electric charge or energy. So capacitance. So the capacitance depends only on the geometric factor and on the material that separate the two conductors. That is area of the conductor separation, whether the space in between is filled with air or plastic, etc. So in this figure we see that there are two conductors with positive and negative charge, and in between the two plates there is a dielectric material. So first we focus on the capacitor where gap is filled by the air. Air is a dielectric medium. So now these are the different capacitors we usually use, like electrolytic. This is old one, this is new one. Then paper capacitor, then mica, then ceramic, then variable. These are some images for capacitor we use in electronic components. Now we see the derivation for parallel plate capacitor. Now we want that C is equal to Q by V. Now here we take a parallel capacitor having area of each plate is A, separation between the two plates is D. So here in figure we clearly see that now dielectric media is air, so E is equal to, that is electric field between the two plates is sigma upon epsilon naught is equal to Q upon epsilon naught A. So we know that there is a relation between E and potential difference V. So V is equal to 0 to D, because D is the separation. E bar dot dl bar. So dl is x axis we take. So 0 to D Q upon epsilon A into dx. Now after solving this, we obtain Q upon Qd upon epsilon naught A. So if I rearrange the term, that is epsilon A by D, this is nothing but C. So we got V is equal to Q upon C, or you can say the capacitance C is equal to Q upon V, or we can say epsilon A by D. So this is the capacitance of parallel plate capacitor. Now we see the spherical capacitor. Now we take a spherical capacitor of radius B, which is outer plate, and for inner plate the radius is A. So concentric spherical shells with charge plus Q on inner shell, then minus Q on outer shell. So according to the Gauss's law, E bar is equal to Q upon 4 pi epsilon naught R square. So the potential difference we obtain A to B, E bar dot dl bar. A is initial position, B is the final position. So we obtain A to B is like this equation. K is nothing but 1 upon 4 pi epsilon naught. So we got minus K Q R A to B. So after solving this, Q upon 4 pi epsilon 1 upon A minus 1 upon B. So this is the equation of spherical capacitor. In previous section, we find the derivation of capacitance for parallel. So in spherical, now we see this type of Q upon this thing. Now Q get cancelled, so we obtain 4 pi epsilon naught AB upon B minus A, because we know that C is equal to Q upon V. So in initial PPT we see how to find V. So for isolated capacitor, if I say where P is very greater than A, then this part is becomes negligible, and your equation now becomes C is equal to 4 pi epsilon naught. This is for isolated sphere. So in general, we can say for spherical capacitance, this is our equation 4 pi epsilon naught AB upon B minus A. Now in third case, we see the cylindrical capacitor. Now we take a cylindrical capacitor with inner radius A and outer radius B, and the length of this capacitor is L. So in inner rod plus Q, then outer rod is minus Q. So again we find out first V according to the relation of E. So we know that E for cylindrical capacitor Q upon 4 pi epsilon naught R into L. So by putting these values, we obtain this equation Q upon 2 pi epsilon naught L ln of B by A. B is the outer radius and A is the inner radius. So finally your C for capacitance for cylindrical capacitor Q upon V, we obtain 2 pi epsilon naught L divided by ln of B by A. So this is the equation of C for cylindrical capacitor. So finally we see summary what we learn in this PPT or in this section. Any two charge conductor form a capacitance. Then capacitance is equal to C equal to Q upon V. For parallel plate equation is epsilon A by D. For spherical 4 pi epsilon naught AB divided by B minus A. And for cylindrical capacitor C equal to 2 pi epsilon naught L divided by ln of B by A. So this is the information regarding the capacitance. Thank you.